Last time I showed you guys this camera I made, but I didn't show you how to make it. So today I'm going to fix that, going over the 3D printed case, the wiring, and the software. Starting out with the case, there's a lot of issues I had with the original design, and I think that I fixed just about all of them inside this new version. I also added a new space for a button that replaces the old push button. This works, but it's just not great, so I'm going to show you guys that upgrade later in the video. But to replace this case, we're going to first have to tear it down. So let's do that. Starting with, you're going to need a Raspberry Pi. So this is my Raspberry Pi 4B with 8 gigabytes of RAM. You don't have to get 8 gigabytes, but the more the better depending on what you're planning on using it for. You also are going to need a micro SD card. This is a 64 gigabyte one, which is good enough for what I'm using it for. And then hopefully in the future I can figure out how to get expansion ports and stuff. So you can actually have like a SD card, just like a normal camera, then just export the media onto that, take that SD card out, put it into your computer, get the data off of that, then plug it back in. This is the HDMI adapter. So the Raspberry Pi doesn't have full-size HDMI, which is kind of annoying. You can see right here what it has. It's just these, I think they're micro HDMIs, but then the display that I'm using actually does have that full-size HDMI on it. And whenever you get this, it's not going to have the fan connected. So you are going to have to connect the fan yourself, but they have really good documentation for it. You literally just plug in these two pins, and they're labeled red for power, black for ground, and then it has like two-sided tape on the fan that you just stick on this. There's also some heat sinks on my Raspberry Pi now, so those aren't factory. They actually did come with the display that I got off Amazon. And that's just going to make it a little bit cooler whenever it's running, because there's going to be some more power that's going to be used because of the display and such. So looking at the 3D printed parts, this is kind of like the top part, while this right here is more of the base. So what we're going to do is we're going to start by attaching everything to the base of this, so the Raspberry Pi to the base of this, and then we're going to build up from there. So what I'm going to do is I'm going to take my Raspberry Pi, already have all the heat sinks installed, and then I'm going to plug in the micro SD card. So just like this, shove that in. Then I'm going to take it, I'm going to place it on top of here. So we got the 4 holes on the bottom plate, and we're going to line that up with the 4 holes on the Raspberry Pi. So you got 1, 2, 3, 4 holes. Just going to line that up. Now what we're going to do is we're going to have these small little screws right here. These are going to be going into the bottom of these. So just like this, but through the plastic housing. And then we're going to have these pegs going up from the bottom of the Raspberry Pi for now, in order to just give it a little bit of space. So you can see there's a little bit of clearance there now, or there will be. And that's going to just allow some more airflow, which will help with the cooling. So you don't have to have a screwdriver for this, but I find it useful just as a little bit of an aid. Makes it a little bit faster as you're just going through this process. So I'm going to just use one of my Phillips head bits. Make sure that that fits on there pretty good. What you don't want to do is strip out the screws, because I only have the ones from the Amazon screen for a lot of these, so it's good to not mess those up if possible. Alright, so what I like to do is I stick the screw through first, and then I start to just kind of finger thread this, so I can get that in frame. All you're doing is just kind of threading it on a little bit, and then you can use the screwdriver to tighten it down. It doesn't have to be real tight, but just make sure it's on there, and you should be good. Realistically, 4 of them is probably a little bit overkill for this. I mean, it's just like a prototype. You can definitely take it out and use it, but if you want to do a little bit less just to make it easier to assemble and disassemble, be my guest, it really doesn't matter any. Now that you have it like this, what you're going to do next is take your Raspberry Pi and then try to just place it down right on top of it. If you printed everything correctly, it should just go right there on top of it. Now what we're going to do next is we're going to actually lock it down a bit. So what you do is you have these little nuts right here. You just screw these on. So this is kind of a pain to do. It's really not much to grab onto. what I found can be helpful is getting something like these wire strippers, and then you can use that to kind of grab onto it for some of these, especially when you're just getting it started. But for this one, I'm going to try to get it just finger tight, because not everyone's going to have the wire strippers. See if I can get that working. This is one part of the process that I am trying to fix. And by fix, I mean just if I could make this a little bit easier to work with, I definitely want to do so. So in another part of the design, I have what's called a captive nut, I believe. So you can see that one's on now. So what you do is you basically take one of these little nuts right here, and you kind of embed it into the 3D printed plastic. And that can just make it a lot easier to actually assemble it and to get everything on tight. So that's one aspect of this where I'm really considering doing that. So instead of having the post come out like this and have like another screw going through it on the bottom and then the post and then this, what you could do is you could just have the 3D printed post go up and then have the nut inside of that and then capture it with the same bolt that's currently being attached to the bottom of this, assuming that the threads are the same, which is something that I do need to check before I continue with it. But I can also just buy more hardware if I need to, or use existing hardware, buy different nuts, that kind of thing. Lots of options for it. It is nice to use actual hardware going into actual hardware instead of just screwing directly into plastic, which is an option. Some people don't like to do it. I think it's fine for a lot of projects. Something like this, where ideally you're only assembling it, disassembling it maybe once, should be fine. This one right here is the most difficult, just because there's so much stuff around it. So it may take me a second to get it. For a lot of stuff, though, it's really not that big of a deal to just screw right into the plastic. And as long as you're only doing it a couple times, it's just not a big deal. It's completely fine for a lot of projects. That's why I would definitely recommend for people getting into designing their own stuff to be 3D printed. I think it's fine for a lot more projects than people think about. Like I see heat set inserts are super cool. It's just like that's extra hardware you have to get. You can see that's on there pretty good. That's extra hardware you have to get. So if you can avoid extra hardware, generally that's a nice thing. Okay. So that's done now. So the next step we're going to do is we're going to actually wait a second before installing the camera, and we're going to look over at this piece. So this piece is going to actually have that captive system that I was talking about. So you can see in here where you have these hex nut patterns, and you have these standoffs right here. So what you do is you have 4 of these, and you have 4 holes. What you're going to do is just push it down right into here. You're going to want to get that pretty well pushed into it. There you go. It should go just a little bit below this. So that's when you know it's pushed in enough. If you run your finger over it, it's going to be a little bit recessed below the wall. That's so that everything gets on there properly and there's no gap. So I like to use just a screwdriver or whatever else in order to push it down just a little bit. And as long as you have that little gap between the wall and it, you should be fine. That was one part of the design where it took a couple of tries to get it just right, but that's kind of where I found it just works the best. You can also use your wire strippers here as well, if you have them, to just push it down a little bit farther. Just really get it down in there. And that should be good for all those. So yeah, that's looking good. So here's one part that I've been looking at where I was talking about adding key switches. So this actually just snaps in right here. It only works in one direction. These are slightly longer, on one side than they are on the other side. So you had to put it in like this, I believe. So just like this, and then you just push it down real tight, and there you go, that's in now. We're actually going to take it out because I need to solder the wires to it first. I'm going to just do a quick fit test to make sure that everything still lines up. You can see these 3 alignment poles right here. So 1, 2, 3. That corresponds with 1, 2, 3 on the bottom part to make sure that it's properly aligned. Just a little locating feature. And if you look at this, you can see that there's still a little bit of space there. So I'm going to add the screen as well to just really make sure that everything fits before we go through the whole assembly process. The keyboard switches should be pretty standard. So if you order a different type, they should all have around the same length of the stems. But it's just a good thing to test. Make sure everything's properly toleranced, everything's working properly. So I'm not seeing anything bump into anything else. So it looks good on my side. It fits properly. And you can see what I was talking about where if you look at it, there's no gaps on the corners. So if those posts were just a little bit farther out, there'd be a gap on the corners, which would just be a little bit uglier. And then, you know, it's not crucial. It's not like this is something that's, you know, it doesn't have to be perfect. It's a 3D printed project, but I want it to look nice. So doing my best to make it look nice. So just to kind of demonstrate once again that this is a button, that's all it is. I'm gonna get my multimeter out. If you don't know what a multimeter is, it basically just measures a lot of electronic stuff. So I'm gonna actually go to this setting right here and then push select. That's gonna get me into continuity mode. So what continuity mode does is basically if there's a connection between the red end and the black end, it makes a beep noise. So I'm gonna test it on one of these key switches. So right now, if I connect it to this one, then I connect it to this one, nothing's happening. But if I push the button, it makes that beep sound. Let go, it stops. Push the button, it makes a beep sound. So that's how you know it works just like a normal button and that it's not like fried. There's not any short in between these 2 connections. So this is a fully functional key switch. And then we can just solder right onto that and use it just like the button that we are currently using from the previous design. I think this one's going to be a lot nicer though. Time for soldering. Here's my soldering iron. It's a pine seal. It's probably one of the best like soldering irons you can buy. For like under $100, that is. I really like mine. And then here's the solder that I'm going to use. It's just from literally Harbor Freight, I think. But it's just some very fine electronic solder. Don't get the thick stuff. The thick stuff is not easy to work with. Looking at our old one, we can see these, I think they're called DuPont connectors. So they basically just go right on top of the pins for the Raspberry Pi, and it's just a really easy way to connect to them. You don't have to get these. They're pretty cheap on Amazon, and I definitely recommend it as opposed to soldering onto the pins themselves, if possible. So I would look into getting some as you're just going through the parts list. What I'm going to do, because I have the ability to, is I'm going to just cut these wires off right here. That's going to make it just a little bit easier for me. I'm going to show you exactly how I did it. So all you're going to do is you take the DuPont connector right here, you cut it off, and then using some wire strippers, or you can use a pocket knife, whatever you need. You just strip the wire back. What I like is this 22 gauge wire from Amazon. It's literally just this company, 22 gauge wire. I think this is the brand. Really, really good stuff. Super useful for Arduino or Raspberry Pi projects. You strip that back and then you just solder it. So all I'm going to do is I'm going to strip this back some, solder one wire to this pin, and another wire, this red one, to the other pin. You see I have a paper towel here. That's just to get solder off. It's called temperature shock, I believe. And it just keeps the tip clean for it, which is helpful for just clean solder joints. I always solder on top of cardboard or something just so I don't get my desk permanently messed up by solder. Just gonna strip back just a little bit. You don't want too much. Ideally, you'd have like, I use hot glue a lot, but some sort of way to isolate the points from each other so they can't possibly short. I don't have that on me tonight, but that's something you can add later on if you need to. But basically just try to minimize how much wire you're using, and then you should be okay. So what I'm doing now is I'm trying to wrap the wire around it just a little bit, and that's going to make it just a little bit easier to actually go on here. Sometimes it's hard to get it to stick, so you just kind of have to work on it. Just work at it just a little bit. There's a really useful tool. It's called a helping hand. It makes soldering stuff like this way, way easier. It basically is just, as it said, like a second hand, so it just grabs the stuff for you. I don't have that with me right now. And I can show you by doing this that you don't need it, but it is helpful. So if you have a little bit extra room in the budget, I'd recommend grabbing one. I'm gonna just get my soldering iron up to about 300-ish, 310. That's generally the range I like for soldering. Maybe go a little bit hotter on this, I'm not sure. I've been using this for some other stuff, so I'll go 330 with it, see if that works. Oh, there it goes. So what I'm going to use is an air filter, just to kind of capture those fumes. You don't want to breathe this stuff in. So you can see that's on there pretty good right there. It's on there pretty good. And I'm going to just do the same thing for the other one. Okay. So you can see that's on there good too. This is on there good. And I'm going to just do one more test with the multimeter. Just to really make sure that I didn't bridge anything. Sometimes if you get stuff too hot, it can just fry a lot of stuff. So that looks fine. Then if I push down on it while doing this, I can grab onto it still. There you go, still works. Perfect. So now, being careful to put the cords in first. I've messed that up before. Make sure you put the cords in first. Put that in. And then remember that orientation that we talked about. So it has to go in specifically this way. So not this way, but this way. Push that in. Boom. Very nice. All right. I'll unplug my soldering iron. Make sure you place that somewhere where it's not going to burn anything. This tip's still going to be hot for a second. And we can get on to the next step of assembly. All right, perfect. So we got that part done. We got that part done. What's next? The next step is actually going to be installing the camera. After that, it's pretty much plug and play. So you can see on my screen, the orange cable is going to go on this pin right here. And then the black cable is going to go on this pin right here. So I'm just going to reference that while I plug these in. So black one goes here. Orange one goes here. See? just like that. And then testing the fitment one more time. Everything plugged in. Looks good. All right, next step is going to be routing the camera wire. So this is the camera connector right here. And then this is where the camera plugs in. So it plugs in right here. So what you're going to want to do is you're going to want to have these sides of the pins hitting this white side right here. So I'm going to plug that in like this. Right here. And then you just carefully push down these little black connector pieces on either side of it. It's right here and then on the other side, just like that. And then you have your camera connected. So how I'm trying to run it, I'm trying to kind of loop it around like this. It's a little bit confusing, but kind of looping it around like this. You can see that. And then it's going out of this hole right here. So I got a hole right here for it. And this is one of the last things that you have to plug in. So we'll mess with that in a second. That's how it works. It goes around like this, goes out, and then it goes onto the front right here. And unfortunately, there's still quite a bit of slop on the cable, but that's something I'm going to work to resolve inside of future designs and revisions. Everything's open source though, so if you have any ideas on how to fix it, be my guest. Please do. Okay. Before you close everything up, you're going to want to start on the software section. If you don't have the SD card inserted with the actual software installed on it, it's going to be very, very difficult to access it in the future. You're going to have to unscrew the whole device, so let's just do it right now. To start, you're going to have to go to raspberrypi.com, and then you're going to download the Raspberry Pi imager. So I'll show that on screen for you. All you do is you just scroll down and then download whatever is relevant for your device. So Mac for Mac OS, Windows for Windows. I already have that installed, so I'm just going to open that up real quick. With that open, it's going to have a couple options that you need to select from. So there's going to be storage, OS, and then a write button. So you're going to take your SD card. You're going to need one of these SD adapters most likely, but it probably just comes with it inside of the box with it. Then you're going to need something to plug it into your computer with. For me, that's this. Just going to plug that in, plug that into my computer. And now whenever I click on it, it's going to have an option called Choose OS. So here's the tricky part. Do not download the latest version. You're going to scroll back a little bit to Legacy. So you go to Raspberry Pi OS Other, and then you scroll to Raspberry Pi OS Full, but Legacy. So you're looking for Debian Bullseye. Depending on when you watch this video, there may be an updated guide that can actually use Bookworm, which is the latest release. So check the links in the description below the like button to actually see that. I'm going to have a GitHub with a full wiki that's going to teach you step-by-step what to do. So if you prefer a written guide, you can look at that as well. But the biggest thing is, for now, if you're watching this recently, download Bullseye. That's the only way I was able to get it to work. So tap Bullseye, and then choose storage. This is very important. If you have an SSD or other storage device and you click the wrong one, it will wipe it, which you don't want. So what you're going to want to do instead is just be very careful. So if it's a 32 gigabyte SD card, this is going to say 32 gigabytes. So click on that, and then click the cog button. It may have a pop-up or some sort of prompt for you, but basically all you're going to do is scroll down, and here you can set your username, your password, your Wi-Fi network, as well as the password for that. And you can also do your wireless LAN country, time zone, and then keyboard layout. It's just going to save you a little bit more time whenever you actually get this done and booted. Push save, and then push write. It's going to have a pop-up that says all existing data will be erased. And I already have the proper operating system installed on this SD card, so I'm going to push no. But for you, push yes, and then you're going to have to wait a little bit of time. Maybe about 5 minutes. Once that's done, all you're going to do is pull the SD card out, take the micro SD card out, and then insert it into the Raspberry Pi. So I'm going to switch cameras. Your Pi should be around this state. You may have to remove the screen again. All you're going to do is just going to rotate it around a little bit, and then it can be a little bit tricky, but you're going to take the SD card and then just shove it right down there inside of that SD card hole. So I missed it there. And there we go. So then I'm just going to put back on this adapter as well as the screen support. And then the screen, making sure that all of our cables are still tucked where they need to be, looking at this camera cable, and then install the HDMI to micro HDMI adapter. After that, we're going to need a couple things: keyboard, a mouse, and some way to power this. So this is going to be the first boot of the operating system, and it will take a little bit. So don't be shocked by that. It will take a little bit on the first boot, and then it'll get shorter on the boots after that. So right now I'm just plugging in the mouse right here. And I'm also going to plug in the keyboard. Okay, that's now booted. I'm going to just rotate the screen so you can see it better. Sorry, I wish there was a better way to capture the screen, but I can't really find a better way to capture it. So basically what you're going to want to do is start by updating. So you're going to want to use the mouse in order to go up to the terminal. Once there, just left click on it, and then you're going to run sudo apt update. That's going to take a second to run. Again, there's going to be a link in the description with everything that you need where you can just copy paste it to make it just a little bit easier for you. Then you're going to run sudo apt upgrade. There we go. And that's already updated, which is great. So now what we're going to do is we're going to go over to a different script here. So what you're going to want to do is type in git clone https://github.com/Boaz the ostrich. Make sure you capitalize the capital B, and then PIBZ all capital .git. Forget. All right, now that you're there, what you're going to want to do is using the mouse, go to the browser right here, scroll all the way down to PIBZ, double click on that, and then you're going to have a couple options here. So what you're going to do is right click on the README and then go to text editor. And then you're going to have a URL right here. It's going to have that link to the software guide actually on the device. Just make it a little bit easier for you. So I'm just a little bit of difficulty copying that, but I'm going to get it. So just copy like that, and then you can go to your web browser and then just paste that URL in. And I'll make it just a little bit easier for you. May take a second for the web browser to load. This is the first boot for everything. Once here, you can just right click and then paste that in, making sure that it just ends with software right there. And that's going to have all the different commands for you. So I'm going to scroll down until I get to the commands, and then here under driver install, what you're going to do is you're going to copy paste this. So copy that, paste it in, push enter. Then you're going to go over to here, copy that, paste it in, hit enter, go over to this, copy it, paste it in, hit enter, and then copy this, go over, paste it in, enter that, and then run this one command. But before we run it, I'm going to show you something. So using this stylus right here, you can see that currently we have no touch input. So no matter where I touch on this display, nothing's happening. The point of this driver is to make it actually recognize the touchscreen, and then using that, we're going to be able to actually operate it properly. So it pops up a little message that says need to update touch configuration. You can ignore that for now. We're going to do that in a second. So it's just going to run all these commands, and then it's going to reboot, which will take a little bit of time. So now, if we use that same touchscreen, or stylus, you can see that the touch response is actually really, really good. The issue that we're running into right now is we wanted the screen to be flipped. So what we can do is we can go back into the terminal, and a quick way to do that is to push Control Alt and then T, or you can just click it with the mouse. Either way works. So I'll demonstrate that for you. It's going to pop that up for you, and then if you just click the up arrow key, it's actually going to make it a little bit easier for you, and you can already go straight back to your cd.lcd show. Then all you're going to do is you're going to run one more command, and that's going to flip the screen 180 degrees for you, nice and easy. Type this, and then right after you're going to type 180. So it's going to just flip the display 180 degrees, and then it's going to reboot as well. And then it will be the proper orientation for your device, unless you want to just flip it over. You can absolutely do whatever you want with this. But for me, I prefer for it to be flipped 180 degrees. And then after that, reboots, I'll show you how to calibrate it in case the built-in calibration's a little bit off. It's been pretty good for me, but it's nice to have the option just in case there's some sort of edge case. I'll rotate that, just make it a little bit easier to see. And now you can see if we use the touchscreen, that's working properly. And if I want to select, say, this icon up here, that works fine for me. But in case you do need to calibrate it more, you can go into here, and then all you're going to do is you're going to type in sudo apt-get install xinput-calibrator. That's going to ask you, actually it's not going to ask you anything. Once that's run, you now have an option inside of this menu up here, underneath preferences, to change your calibration settings. So you can push calibrate, and then if you just use the stylus, clicking these little dots, it's going to calibrate your screen specifically and give you a couple of different options for you to paste that into the command line. So you can see right here, you got options where you can copy paste this into this folder. So it's going to be the etc. X11. So all you have to do for that is you're going to right click it, push copy, open up a separate terminal window, and then you're going to type in sudo nano, and then you're going to right click and then paste that text in. And that's going to have the current configuration. So if you want to replace it with a new calibration, you can literally just select all of this text, right click on it, push copy, go back over here, delete all the current text. So just literally go down to the bottom and then delete everything. And then right click and then push paste. Then you're going to push Control X, Y, and then enter. So that's going to have the new updated values, and so that's going to save throughout multiple reboots. So it's just always perfect for you. So now what we're going to do is we're going to go into the Pi icon up here at the top. We're going to go to Programming, and then we're going to go to Thonny. Once we're in Thonny, we're going to go to Load. And then if you go underneath PIBZ that we downloaded earlier, there's going to be a file called buttonv3.py. So that's the one that you're going to want to use. So click on that. And then all you should be able to do is just push Run. And you might encounter Enter. Yep. So there's an issue that says failed to allocate buffers, cannot allocate memory. So what we can do to get around that is go into cd/boot. And all this again is on the GitHub wiki. Then if you type ls, it shows you all the different text in here. What we're trying to mess with is config.txt. So just like earlier, you're going to type in sudo nano and then config.txt. That's going to have a whole lot of options for you. What you're going to do is scroll down until you get to an option that says this right here, DT overlay VC4. So right now it's commented out, that's why it was blue. So I'm going to uncomment that, and I'm going to add one more command after it, which is CMA 320. So CMA-320. That's just a little bit of extra memory for you, and that's going to make the camera run way better. Right now it's not even running, so it's going to run a whole lot better than not running. So you're going to push Control X, Y, and then Enter, and then do sudo reboot. I know a lot of this can look really, really intimidating when you're looking at it, but I promise it's not that bad. It just takes a little bit of getting used to. And if you need any help, I respond to every single comment, read every single comment, so I'll be sure to be there to help you if you need it. So it is going to mess up our rotation, but I'm going to show you how to fix that. Instead of going to the command line again, if you can see with this, it's messed up a little bit. But instead of having to go through the command line and everything, what we can do is go over here, go down to Preferences, and then go to Screen Configuration. And inside of this, you can right-click, go to Orientation, and then click Right. Then you're going to apply that, and then you're going to push Yes. So that's going to just reboot with the new orientation. Looking at that, we have the proper orientation. You can see that the cursor is tracking exactly with the stylus. So that's just what we want. And then what you can do is you can go over to Thonny again. And this time, it'll work. So go to Thonny, and it should still have your file open from last time. Or if it doesn't here, what you can do is you can push Load, go down to PIBZ again, and then click on Button V3. So if you run that, you're going to notice that it doesn't have that same error as last time. And there we have a preview window. It doesn't have the lens attached currently, so that's not going to display properly, but what we can test is pushing the shutter button. And you can see inside of this window here that we did actually capture a picture. So if you want to see what we captured, you can push Stop, and then going back to your File Explorer, and then Desktop, you can see your Images folder, and you can see right here that says 65. So I'm going to actually delete this photo. I'm going to show you how to change it so it has a proper number for you. And this is also going to be available just on your desktop. So there's now going to be an images folder there to hold all your images. So what we're going to do is we're going to go back to File Explorer, go back to PIBZ, And then underneath the pips folder, there's a file that's called picturecount.txt. If we open that with the text editor, we can change the number in here to 0. And then whenever you start taking pictures, you're going to know exactly how many pictures you've taken with this camera, which I think is a really cool feature. You don't have to change it if you're okay with just it being 65, but I think it's a cool feature. And yeah, I like it for what I've been doing. So that's everything. You now have a functional camera, and you can continue with assembly. So making sure everything is still positioned properly. Just drop that in. This cable comes over just a little bit. Everything looks good to me. All right, so now take your screwdriver, screw this in just a little bit. I'm gonna just put in 2 for right now. We can put in more later. I think I got everything properly installed on the internal, so we shouldn't have to open it back up. But just in case. So that's installed. Let's work on the camera. So as you can see, the camera has 4 places that needs to get screwed in with these 4 poles. And all I'm using for that is just some of these small self-tapping screws. So you got a couple different sizes. I'm using the smaller ones. I think they're 2.6 by 6 millimeters. And those have worked really good for what I've been doing with it. Let's start screwing those in. You don't got to get it too tight. I've had posts break off before. That's one of the bad things about 3D printing and connecting directly to the plastic part with screws, especially self-tapping screws, is if you go too crazy with it, you can mess it up and actually strip it, which you do not want to do. So just keep an eye out for that. It's not like a massive deal, and I mean, you can just reprint the part. Or for something like this where there's 4 posts, if one of them breaks off, it's more of an aesthetic thing than an actual function thing. Your camera module should not be falling off because one of the posts is missing. You could probably do it with 2 and be fine. 4 is a little bit overkill, but I like that it's symmetric, so it's fine for what I'm doing. So we've got 3 more self-tapping screws here, and those go on to the variable grip that I was talking about. So this is just the grip that I'm using, and you can see there's a little slot to kind of show you what direction it goes, because you don't want it to overlap with the hole right there. Switch to a slightly bigger tip for these. And you don't have to. You can use basically whatever Phillips screwdriver you want for this, and you should be fine. It's just a little bit nicer. And then for some other projects where it's a little bit more critical, it is nice to make sure you're not messing up the top of it, just stripping it out or anything. So if you're reusing them, then it just looks a little bit nicer. So that's it. And with that, you basically have a finished camera. You can screw in these front panels, and I will do that, but it's not really necessary because as you saw, I really pushed those pegs down in there. It's just one of those things where it looks a little bit nicer, and if you care about that, I care about that, then it's good to have. So I did a little bit of assembly off camera, so now you got all 4 of these installed, all 4 of these installed, and everything is just perfectly, just about done. The last thing is installing the actual camera lens. So you just remove that cap, and then depending on what lens you're using, you may or may not have to use this additional adapter right here. So this is a separate piece that just screws onto it to make it actually fit on it. For the 16mm lens, you do need it. And then you just screw that on. And with that, you have a completed PIBZ camera. You can add a keycap, obviously, and I'll add one at a later point, but that's a much nicer click than I used to have. And there you go. That's the hardware done. Here's the completed camera with the keyboard cap. That just sounds so good to me. It's gonna sound better in the future, and I have a plan to try to make it hot swappable so you can make it sound whatever you like. But, it's so much better than it was. And we can compare that. So this is the original, and then we got, I like it a lot more. Thanks again for watching. I hope that you have a camera now that you can just work on your own projects with, and that's amazing. You did great. Thank you so much for watching. I'm sorry it was so convoluted, such a long video. I'm working to cut it down, but yeah, hope you enjoy.